Hey builders and welcome back. In our last video, we explained why embedded wallets are a game changer. Today we are going to show you how. We'll build a complete application from grounds up using Next.js and the Coinbase Developer Platform Embedded Wallet SDKs. We'll cover project setup and configuration, integrating Auth using React components, building a custom UI using React hooks, sending transactions to Base and the other EVM chains, and integrating the ecosystem using wagmi. By the end of this, you will have a live on-chain application and all the knowledge you need to bring a seamless UX to your own projects. Let's get building. First things first, let's get a project Bootstrap. So I'm already on my terminal over here on the desktop directory, and here we'll use the create-cdp-app command to bootstrap a quick project. So we'll use npx at the Coinbase, create-cdp-app at the latest, and then the project name. So here it will be my embedded wallet app. So I'll just click enter after this. So it will ask for installation permissions. Once that is done, we click Y. So now we'll choose a template. We'll go with Next.js as discussed before. And next, you will need to find the project ID. So you can find the project ID from portal.cdp.coinbase.com. So here at portal.cdp.coinbase.com, you can find the project ID on the dashboard itself. So here is the project ID. You will just copy this and paste this here. So you are able to find the project ID from portal.cdp.coinbase.com. Once that is done, we'll hit enter. Now the next thing is to whitelist the portal localhost 3000 at portal.cdp.coinbase.com in the embed wallet configurations. So navigate back to portal.cdp.coinbase.com, and here in the wallets you can find the embed wallets option. Click on this, and here you can add the domains configuration. So this domains configuration is important to make sure that the domain that you're testing with is whitelisted and you are able to access the embedded wallets from that particular domain. So in this case, we'll be just testing on localhost. So we'll be adding localhost 3000. So let's add the domain. So I'll just add localhost 3000 here, add domain. And that's it. We were able to quickly set up the domain configurations as well. The domain configurations are really important when it comes to production as well. So you will have to make sure that if you're deploying an app in production, you are setting up the correct domains, because if you don't correctly whitelist your domains, your apps would never be able to access the embedded wallets, and that means the application might fail to connect wallets or create wallet for users. So make sure that this is done properly. Once that is done, we have a whitelisted a localhost 3000, so we'll confirm it by clicking Y. And that's it. It has scaffolded a project in my embedded wallet app. It copied the project ID to env as well. Once that is done, I'll cd, navigate to the project folder, my embedded wallet app, and I'll hit npm install to install the dependencies. So we are done with the dependency installation as well. Now let's open up a project in the IDE and set up the envs and get started with the project. You are not going to believe how fast this is. We'll use the pre-built components from Coinbase CDP SDK React package to get a full auth flow in just about a minute. The starter template already has a great structure for this. So you can just navigate to the SRC folder, and in that, you'll navigate to the components folder, and here you will find the providers.tsx file. So in the providers.tsx file, you will find the CDP React provider already set up. So this wraps our entire application and provides the necessary context for the SDK to work with. So first of all, we have some imports, the necessary imports like CDP React provider from the CDP React package and theme from to get the components theme. Once that is done, we have some interface and the CDP config where we'll use the next public CDP project ID that we set up while bootstrapping this project. After that, we have the app config where we keep the name and the logo URL for our application. So in this case, it's CDP Next.js starter kit with the logo URL. And then we have the important component. So this is a providers component that wraps our application in all requisite providers. So here, as you can see, the children is an entire application, and the CDP React provider wraps the entire application, providing the necessary context. Next, we have the client app.tsx component, which handles what to show based on whether the user is signed in or not. This is a great pattern. It keeps our page.tsx clean. But we'll simplify this client app.tsx for our demo, and we'll just use the auth button to show how the auth button works. So I already have the simplified version. I'll just copy it over here. So Command A and Command V. So this is a very simplified version which uses the auth button and uses initialize from Coinbase CDP hooks and Coinbase CDP React to initialize the auth button. So here in the client app, you can see we have first initialized the variable is initialized using uses initialized hook from Coinbase CDP hook. And if it's not initialized, it will show the loading component, and if it's initialized, it will show the auth button component. So once that is done, we will navigate to the app folder, and here we'll navigate to the page.ts. So here, as you can see, we have the main configuration for our Next.js application. This would be the main home page. So here there are two imports. One is the providers import, which we just discussed, and the client app import, which we just modified for our auth button component. Let's run our application and see how it works. So I'll just run npm run the. So localhost 3000, that's correct. Just go to localhost 3000. And as you can see, we can see the auth component over here. So let's click on the sign button and see what the auth component can do for us. So we'll click on the sign button, and as you can see, we have a UI over here. I'll just use one of my emails, connect with email. Let me just quickly go to my mail and get the verification. 2371. And yeah, we were successfully able to sign in. And just like that, with the structure provided by the starter kit, we have a secure self-custodial wallet login by CDP Embedded Wallets. It's that easy. The auth button is great for speed, but what if we need full control over the UI? That's where the CDP SDK React Hook packages come in. Let's build our own custom login form. So I have built another TSX file over here, custom auth.tsx, where we have built our own example of the login form. So first of all, you have to import the various hooks from the Coinbase CDP hooks package, like use sign in with email, use verify email OTP, use current user, use sign out, and use EVM address. So what we'll do is that we'll combine these various CDP hooks to create our own login form. And then we'll import the use state from React. After that, we have a function custom auth, where we set up the various use state variables for the custom auth flow. So first of all, we have the email use state variables, the OTP use state variables, and then the flow ID use state variable. So flow ID here is one of the response parameters from the use sign with email CDP React hook. So once that is done, we will initialize the various variables from the hook. So we have the sign in with email constant with use sign with email hook, and then we have the various hooks being initialized here, the use verify email OTP, use current user, use sign out, and use EVM address. And after that, we have the two functions which would handle the sign in and handle the verification. So here in the handle sign in, we'll deconstruct and use the sign in with email hook. So we'll basically make sure that the flow ID response is being captured properly and set up in the use state variable. So set flow ID will set up with the latest flow ID that we get from the sign with email CDP hook. And after that, we have the handle verify function, where we verify the email OTP using the flow ID response and the OTP that we have that has been given from the user. Once that is done, we'll make sure that if the user is set up, we return particular React component like welcome user.email. So you can get the email from the user response, and you can also get the EVM address as well. And you can keep a sign out button as well, where if the user clicks the sign out button, the user is signed out from the wallet. And rest, you can create the JSX for the email and OTP input forms depending on how you want to design the UI. Also, just for an example, I have added some UI over here to show the difference between how the default login works and how the custom sign-in login works. So I have added some input CSS properties, and here I have added some functions to like handle the sign-in, handle the verification, handle resend, and then make sure that the JSX is called properly set up with the CDP embedded wallet packages as well. So I added some JSX here as well. Once you have added JSX and you have completed the component, you can move to the sign-in screen.tsx, or wherever you have kept the sign-in components and their configuration in your application. You can just move on to the file, and here you can add your custom auth component. So here in the sign-in screen, I have added custom auth component, and I've also added another option where if we prefer the default UI, we can use the auth button UI as well. That way we can see the difference on how both of those work. By using the CDP React hook, hooks, you can build any UI that you can imagine, and CDP handles all of the complex transactions or complex wallet building in the background. The next part is extremely important. The way you send transactions differs depending on the network, and getting this wrong is a common source of bugs. So already I have an example which I will go through and explain you how to send transactions based on networks. So here I have created another component TSX, which shows you how you can send transactions depending on networks. So first of all, we'll have some basic imports like making sure that we have imported all of the proper components and functions from the CDP hooks like use send EVM transaction, use sign EVM transaction, and use EVM address. And then we have VM utility imports like create public client and HTTP. And then we have the Sepolia chain import to show you how you can transact on other EVM chains as well. After that, we create the public client using create public client on the chain Sepolia and transport HTTP. After that, we have the export default function transactions where we first get the user's EVM address using use EVM address. So we'll store that in the constant EVM address. After that, we have the hook for base. So transactions on base and transactions on other EVM chains work very differently. And I'm going to show you the difference. So here, first of all, we have the hook for base. So uh, transactions on base are a one-step transaction. So any kind of transactions on base using embedded wallets are a one-step transaction. So we'll use a use send EVM transaction and we'll show the context in send EVM transaction. And then we have the hook for other chains. So this would be a two-step process, and I'll explain you how. So here we will use a use sign EVM transaction. So for base chain, you can directly use a use sign EVM transaction, and for any other EVM chain, you will have to use a use sign EVM transaction. After that, uh, we have the main component which handles a transaction on base. So here we make sure that the EVM address is present, and if it's present, we have a try catch block where we use the send EVM transaction function. So as you can see, it's a single step process. There is no two-step process or there is no additional processes for sending EVM transactions. It's a single step process on base or base Aporia chains. So here we have a single step, which is the send EVM transaction function calling, where we call it with the various parameters like EVM account, network, and the transaction body. So in the transaction body, there would be various parameters like the to address, the value, the gas, the chain ID. So chain ID would be base Sepolia and type would be EIP1559. This indicates that it's a normal transfer. Once that is done, the single step transaction building is done. Then we will just do a normal console log showing success with the transaction hash. And if there are any errors, it will show that the transaction has failed with the error. Now, on base, it's very simple. You can handle all of the transactions in a single step. Now, let's see how you can handle transactions on other EVM chains. So for that, we have created another function, handle send on Sepolia. So here we have this first step, which is same. We'll check if the EVM address is present or not. And after that, the sending or transactions on any other EVM chains are a two-step process. So the first step would be to sign the transaction. So we have the try catch block here, and in this try catch block, we have the step one, which is to sign the transaction. So here we have the sign EVM transaction function being called with the parameters like the EVM account. So here we have the EVM address and the transaction. And in the transaction body, we have the various parameters like to, value, gas, chain ID, and type. So this is very similar to send EVM transactions, but here uh, this sign EVM transaction will only sign the transaction but won't broadcast the transaction or actually send the transaction. In the case of this, it directly sends the transaction. There is no two-step process. In step two, we will have to broadcast the signed transactions. So any other EVM chain apart from base or base Sepolia would have to broadcast the signed transaction because CDP embedded wallets won't handle all of the transactions for other EVM chains themselves. You'll have to make sure that you broadcast the signed transactions for any other EVM chain. So in step two, you broadcast the signed transaction using VM. So here we are using public client.send raw transaction, which broadcasts or sends the signed transaction. So here we will send the transaction body. And once that is done, we console log the transaction hash, and if there is an error, it throws the error. And then we have the basic JSX which covers that. And that's it. That's the difference between doing a transaction on base chain and on EVM chain. Remember this key fact. On Base, you send, but on other EVM chains, you sign and broadcast. This distinction is the key. What if you want to interact with smart contracts or use the most popular React hooks in Web3? The CDP SDK has first-class support for wagmi. So first of all, let's install the dependencies. So we'll install the dependencies like wagmi, Coinbase CDP wagmi, and TimeStack query. So these are all the dependencies that we need for making sure that we have set up the provider's configuration properly. So I'll just hit enter. So this will install the dependencies. So let's just wait for this. So now that we're done with the dependency installation, let's update our providers.tsx to configure wagmi with the CDP SDK. So I already have the code for modified providers.tsx. Before that, let me just decrease the size of this terminal, and I'll just paste the code over here, and let's go through the code and see how it works. So first of all, we have some imports from CDP React and CDP wagmi. So first we have the CDP React provider import from CDP React, and next we have the most important import for this configuration. That would be the create-cdp embedded wallet connector from Coinbase CDP wagmi. So this is the one which would make sure that the connection is properly established between the wagmi and the CDP SDK. Once that is done, we have the wagmi packages like wagmi provider, create config, and HTTP. And after that, we have base Apolia chain configuration import from wagmi chains, and then TimeStack React query imports like query client and query client provider. After that, we have the CDP connector configuration, which would be the most important change for this providers.tsx. So here, we use the create CDP embedded wallet connector, and the first parameter would be the CDP config, where we provide the next public CDP project ID, and after that we have the provider config, which is used by wagmi. So here the chains would be base Apolia and transport would be HTTP. So this CDP connector makes sure that the wagmi and the CDP SDK are properly initialized and are able to work with each other. After that, we have the config where we create the config using parameters like chains, where we have the chain as base Apolia, connectors where we have the CDP connector. So in the config, we use the CDP connector. And after that, we have the transports base Apolia.id with HTTP. And then we will normally configure a provider with query client. And here in the providers component, we will wrap the entire application with the various configurations that we have done, like the wagmi provider configuration, the query client provider configuration, and then at large, the CDP React provider configuration with the config that we just created before. And that's it. This modifications allows for wagmi to work very smoothly with the CDP SDK. The magic here is that once a user signs in with a CDP flow, the wagmi connector automatically picks up the authenticated state. Now you can use all the wagmi hooks that you know and love, and they will by default use the user's embedded wallet. To ensure true self-custody, users must always have the ability to take their keys and leave. The SDK provides a highly secure method like use export EVM account for this, but there is a highly sensitive operation. So here I have created another component export keys.tsx where I have used this method. So you can directly import use export EVM account from Coinbase CDP hooks, then initialize use export EVM account hook. And after that, you can create a function like handle export where first of all, you keep a warning to make sure that you give a definitive message to user that you are about to reveal your private key. So do not share this with anyone. And your private key is your responsibility. So make sure that you give all of the warnings to the user. And after that, you can get the private key by simply using the export account function that you extracted from use export EVM account hook. After that, in your UI, make sure that you are keeping a proper logic to securely display the key to the user only once. So make sure you're revealing the private key only once to the user if the user has only requested it once. So this is another way to make sure that true self-custody is always there for the user. But again, this is a very sensitive operation and it's a highly sensitive operation. So make sure that you are handling this with utmost care and with all of the proper warnings to the user. Now let's quickly test the starter template application code and see how the transaction works with embedded wallets. So I'll just run npm run dev like before and run the development server. So we'll navigate back to localhost 3000. So it will show us the login screen once again. So as you can see, this time the login screen is different from the one that we used before with the CDP starter kit. As you can see, this time we have added the custom auth component that we have created using our own designs as well. It's very similar to the CDP starter kit design, but as you can see the clear differentiation between the custom auth and the auth button. So you can also create custom auth like this for your own application based on your own application's design. Once that is there, it will ask a verification code. So I'll enter the verification code here. So I have got the verification code from my mail. So 2624074. So we were able to successfully sign the application. So you can see how smooth the login and the onboarding flow is. There is no any kind of extensions or any kind of pop-ups. It's just simple Web2 login flow. So it will create a wallet for us and it will show us some available balance. So let's get some testnet from the base Apolia faucet. So you can go to portal.cdp.coinbase.com and get some base Apolia from here. So I'll just copy this address and get some base Apolia ETH. Let's get more funds because it claims a very small amount for uh, each transaction. So I'll claim some good amount of testnet ETH from here. So let's do this probably 2 more times. Make sure that we have enough testnet ETH. Yeah, that should be it. So once we have got some testnet ETH, let's send a transaction and see how that works. So we'll send a transaction to the same wallet on Base Apolia. So let's click on send transaction. And as you can see, there were no pop-ups, there were uh, no login flows, or there were no particular signing flows here. It's a simple embedded wallet flow where as soon as you click the button, the transaction is sent using the CDP SDK, and you can successfully see the transaction hash as well over here. So here you can see we were successfully able to send some testnet ETH using a transaction. So as we can see, the wallet address is same as we sent uh, ourselves some ETH. So this was again same wallet to wallet transfer. So as you can see, it was just a self transfer. So here the flow is as smooth as any Web2 login flows or any Web2 app flows out there. There is no difference between any applications, and this cuts out all of the friction. And now even the mainstream user or a non-crypto user can easily use any application with CDP embedded wallets. And there you have it. And in the 30 minutes, we have built a Next.js app with a seamless, secure login flow, sent transaction to multiple chains, integrated with wagmi, and provided a secure export function. You now have the foundation to build virtually any DApp with a user experience that's ready for millions. For more help, the best resource is the official CDP Discord server. The team and the community there are incredibly active. And of course, you can always check out the official embedded wallet documentation for more detailed references. And for more tutorials like this, check out handlash.com as well. From here, you can explore more advanced CDP features like server wallets for backend operations or base accounts, which leverages account abstraction for things like gaseous transaction with a paymaster. If this guide from Handless was valuable, please hit that like button, follow for more advanced tutorials, and share it with other builders. Also, let us know what you're building in the comments below. Happy building, and I'll see you in the next one.